All right, folks, let's get right into this. I have a collection of bulbs here, and we're going to go through bulb technology so you guys know what you're dealing with when you order things. Now, I might have a couple of these terminologies wrong a little bit because, there's little information on some of these older ones, but we'll get to it. We'll get pretty accurate descriptions. So I want to start off with some of the oldest bulbs that we've ever had, and those are called incandescent bulbs. Incandescent bulbs are the Edison light bulb, the traditional bulb that we all think of. And even though this one here might be halogen, I think this is a pretty good representation of an incandescent bulb. Whereas you have a filament down at the end, and that filament heats up and it gives off photons, and those photons are light. And the other byproduct is incredible amounts of heat. Now, most incandescent bulbs are rated for AC mains. So that means that they run at 120 volts here in the United States. There are other ones, if you have a device that is set up to be on a transformer, it will run at a lower voltage. You can see this bulb here is 6 volt, 4.5 amps, made in Japan. This is a classic bulb. Now this could be a halogen, but I think currently that we just consider this one a incandescent bulb. Now notice that it said it's 6 volt, 4.5 amps. One of the trends that you're going to see across all these bulbs is that we rate them not only in voltage, but also in their wattage or amperage. So that is incandescent bulbs. We all seen them. They've been around for years. They emit a lot of heat. They're very inefficient, and it's the oldest style. Next, we're going to skip over to fluorescent bulbs. Now there's a whole variety of form factors for fluorescent bulbs. Fluorescents, right here, are much lower in the amount of wattage. So a typical incandescent bulb is going to burn about 40, 60, or 100 watts. Now fluorescent tubes usually run at 15 watts, 30 watts, 45 watts, something like that. So much safer. They emit less heat, less ultraviolet, and they have just one downside, is that they require an additional component in order to function, and that component is called a ballast. A ballast excites the gas inside the tube, and that is what emits the photons, and that's what creates your light. So the energy reacts with the coating of the glass, and that's what creates the visible photons that you and I know of, and that's fluorescent. As they get older, they get dimmer, and it's also often containing mercury gas, so that's a pretty big downside. They're not as efficient as some of the others, and they're not as bright as some of the others, which is their limiting factor. So the next mainstream bulb that we still have today is going to be halogens. Now, halogens are going to be very similar to incandescent in that they're going to have a filament that's going to heat up, usually. But the thing is, they use a different gas. They use a halogen gas, and the gas excites versus the filament heats up and it just emits photons. So these guys are kind of cross between these two technologies here, and that's going to be your halogens. Halogens burn really bright. They can create a lot of heat, and notice how I'm using gloves. So whenever you touch bulbs, you should always use gloves, because the oils on your fingers, especially on halogens, because they are a hotter burning bulb, is the oils will embed in the glass and they can create hot spots, and it's really difficult to get those oils off the glass once you start. So these halogen bulbs, they often come packed so that they're in separate compartments, so that you're not going to contaminate the bulbs. They are also rated based on the voltage and the wattage, which you can see right here. So if you see these boxes laying around, you'll see that this is a 100 watt, 24 volt bulb, halogen. There's a whole variety of different halogens out there. It's been the mainstay for the last 20 years. For items that have to be bright but not that bright, it's a very white light and a super bright light. You can see this form factor here. The bulb is actually down inside. There's a light diffuser here on the surface and a parabolic reflector. This is kind of two old technologies. You got dual studs and a twist socket. Haven't seen that in a long time, but we have them here. So that's halogens. Halogens are okay, but they're not bright enough for some applications, and that's why we moved to xenon. Xenon requires these little high pressure bulbs. There's a super high pressure gas inside here, and there's an anode and a cathode, and electrons move from one to the other, and while they're moving, if there's a high enough voltage, it will create a spark, and that spark ignites the gas and creates kind of like a plasma, and it emits lots of photons, and you will see an electronic arc between these two electrodes down inside there, and it's dancing around. So xenon light sources, they're super bright, they emit a huge amount of heat, and it uses a high voltage to ignite the bulb, and then it switches over to a low voltage, high amperage to keep it ignited. So that is what the inner bulb looks like. This is the form factor that you're normally going to see them in. So here you can see these are the electrical contact probes. So that is where the electricity comes in. It goes to each side of the heatsink. So this is a split heatsink. And you can see the rings right here. One ring is going to be the cathode, one ring is going to be the anode. And this guy is going to be embedded inside the heatsink with a thermal compound. And that thermal compound is also going to allow you to transmit electricity. So it's going to be a conductor. So right here, we have heat transfer compound, but it's also to help it conduct electricity from the aluminum heatsink to the bulb case itself. So this form factor here, it's very essential that it's put back together correctly, because this guy is a shroud for cooling. So the air comes through, cools the bulb, because this guy will just run away. It gets so hot. You need active cooling on these style bulbs, and we during the PM have to clean inside here because you'll get a lot of lint, and this gets very hot, and that's obviously a fire hazard. But it's also so that the plastics don't melt. I've seen these melted as well. This is a really high intensity white light. Doctors love it because it's, until recently, the brightest and whitest light that they can possibly get. So that is xenon bulbs. Next, we're going to move to the most efficient. By the way, these xenon bulbs are typically 300 watts. 300 watts. That is a hell of a lot of electricity. That's why it needs a lot of cooling, because with the wattage comes a lot of heat. But our next version of technology is light emitting diodes. So a light emitting diode is just that. It's a diode junction, and when electricity goes from one part of the junction to the next, it emits photons as part of the process, and those photons are visible light that we see. Now the crazy thing about LEDs is that they require a driver circuit in order to function. So in other words, a driver is limiting the amount of current, because it's basically an LED is a short circuit. So what we need is we need to turn on and off that LED at a super fast pace, which you cannot visibly see. The camera shutter will be able to see it, but you can also dim these bulbs, and you can change the color temperature. How crazy is that? Electricity only works in one direction because it is still a diode, so they are not omnidirectional, unlike many of these other ones. Well, except for xenon, they're not omnidirectional. But halogens, fluorescents, etc., those are all omnidirectional. LEDs are not. They do create a bit of heat, especially as you amp up the amount of electricity, but they use very little amounts of electricity. They're the most efficient, and that's why a lot of these flashlights are reverting over to LED technology, is because you can run this guy all day long on one AAA battery. Super cool. I love these little FOBI flashlights. But guys, that is light emitting diode technology. Much easier to control. You can control the dimming, you can control the color temperature, so a yellow light all the way up to a white light. You cannot do that with any of these other technologies. So LEDs are pretty cool and unique in that. However, they do have a couple drawbacks. They require other components in order to function, like the driver circuit. So if I were to connect this LED straight up to a voltage source, it would fail. So there's always a limiting resistor or a limiting driver circuit, something like that, in line to keep it from failing. But that's LEDs, the latest and greatest light technology. Anyway, guys, that's just a little quick rundown on light technology. I've seen a bunch of bulbs. I was just walking by. I figured, what a cool day to do a demo on the various types of bulbs that we cover here at FOBI Medical. It's crazy. Some of these are 20, 30-year-old bulbs, but we still sell them because they still have those kind of light fixtures and stuff out in public. You never know what you're going to get. So anyway, folks, light bulb technology. I know I missed a couple things, but it's the quickest rundown I can give you and a full enough picture with relevant data. Thanks for watching, guys.
If you enjoyed this video, don't forget to give it a thumbs up and subscribe for more content. I'd love to hear your thoughts, so drop a comment below with what you'd like to see in future videos.